Please remember that your test corrections are due on tomorrow. I said that in class when I told you about it on Monday. If you already got them done, then good. They're out of the way. If you don't have them done, then they're due tomorrow. So please make sure you turn them in. Today we're going to continue talking about blood typing, and then we're going to talk about who's your daddy. But before, let's go ahead and just review really quickly some stuff with the homework because some of you were having a little bit of trouble. I'm only going to review this portion of the page because the other page about SpongeBob was really just dealing with Punnett square and figured out information and chance and percentage. This one was a little bit more difficult because it was talking about what?
So many.
But what type of dihybrid? Raise your hand and tell me what's dihybrid. Chappie.
Isn't it talking about two different characteristics?
Talking about two different characteristics. In this instance, it's talking about what two characteristics?
Shape and color.
Shape and color. Now, just before we do this, there was some other terms and some other information. Sit down, Troy. There were some other terms and some other information on the SpongeBob portion that talked about purebred or pure or a hybrid. What's the difference between the two? Pure or hybrid? Brandon. Don't say never mind, Brandon. Just spit it out because then you can see what portion of it is correct and what's not, or maybe it's all correct.
Hybrid is when it's like the DNA combined with each other.
What do you mean?
Like, okay, say like, or say, okay, you got the white woman, you got the black woman. Then, okay, when they have a baby, like.
The two white women have a baby?
Right.
Oh. You didn't learn anything I just taught you?
Sperm.
My bad. Okay, you got a black man and a white woman.
Okay.
Okay, then they have a baby. And then, like, one he be.
That is a misconception. That's actually not what a hybrid is.
Oh, God.
It comes but I understand why you said that because that comes from what actually a hybrid is. Based on what we know about these terms and about these alleles, what's a hybrid?
A hybrid would be if the offspring carries the recessive trait.
Which was called, so if an offspring carries a recessive trait, and in this instance, what is that called? What is that called? The offspring carries a recessive trait. This parent is an offspring of its own parent. But what is that? What is this called when it's a recessive trait? Heterozygous. So a hybrid is a heterozygous allele pair. Got it? Because it carries a recessive trait. It's not pure because it has the recessive trait, which means it could pass it on. What's pure?
If it has two dominant.
If it's two dominant. So this would be pure. Because there's no way this parent could pass on the recessive trait. Got it? That's why we talk about a purebred or dog. You're looking for a dog that actually is pure in whatever breed it is.
So if it was like recessive R, is that still considered purebred?
That's pure because that's only has, yes, that's a good question. If it's this and this, that's pure because it's only going to pass on that trait. All right? Any questions about this? Okay, good. So then having that information, in tomatoes, red fruit is dominant to yellow fruit. Remember, the dominant trait is the letter that's being used. Round fruit is dominant to pear-shaped fruit. A cross between a heterozygous red. Like Drika told us, what's heterozygous mean? What we should put here. What does heterozygous mean, Simon? Two different what? Alleles. Example? Or not example. Let's say, since we're talking about this, so what would says a cross between heterozygous red. So what should that look like? Dominant R, recessive R. Because red is dominant over the yellow, but it's heterozygous. So we know that it's going to be two different. Good. And this also goes with this, across a heterozygous red, round tomato. This heterozygous goes with the color, and it also goes with the shape. So therefore, what should the shape be, alleles be, Brandon? What should the shape alleles be for this first parent?
Dominant B, recessive B.
Recessive B. Everybody good so far?
Yes.
Thumbs up if that's what you got now. And I'm not even going to put you on front street and say if that's what you got before you talked it over with your partner. Just if that's what you had before I wrote it down. Okay, good. Now it says cross of a heterozygous red round tomato plant with another plant of the same genotype. So what should parent 2 look like?
The same exact
The
way.
same exact way. Now, yes.
Okay, so like when I did it, I didn't write the percentages. Was we supposed to?
When you got down here,
Yeah.
yeah,
So we had to put it.
or fraction.
Okay.
Yeah, fraction's fine. All right. Now, before I'm not going to go over all of this. What I do want to know is how do we figure out what goes here?
You can draw a Punnett square on the ball method.
Okay, so we can draw a Punnett square. So over here, I'll just review the Punnett square method, and over here, I'll review the foil or the donut.
I was about to say, what happened to donuts?
Yeah, you're eating them.
Oh.
All right. So the Punnett square method. What will we do?
So you draw your Punnett square.
Okay.
And then.
All right, Chubby. Shh. Let me give somebody else a chance, because you on the ball right now. Brandon already talked. Trika already talked. Hernandez. Dime, tell me. I'm trying to figure out. Let's say I'm putting parent 1 here, and I'll put parent 2 here, but I'm not going to fill it out. I just want to know the Punnett square for parent 1. Can I put it here?
Yes.
I thought you put it
It doesn't matter.
together in one box.
No, that's for the biggest one.
I'm trying to figure out what's actually going to go
Oh, you're right.
here. Remember?
You're right.
So I have to take all of their traits that they currently have, or all of their allows, and put in a Punnett square so that I could come up.
Doesn't matter where you put your R and B.
It doesn't matter here, but it does matter when you get here. You're going to keep it in order. You're going to keep the red trait in front of the round trait, because that's what we're talking about. Or if you do the shape first and then the color, then you just keep that same order. All right? And then we have... And then we do, of course, when we do our dominant recessive, you put the dominant before. But so then we know that we'll get...
Recessive. I'm in dominant.
Right?
Yeah.
Everyone good? Yes.
So does it matter like
I'm sorry.
the order of it?
What do you mean?
Like like for me, mine is switched up. Like I have my dominant R and my recessive B in my first box, and then I have the dominant R and the dominant B in the second one. Like
But-
mine's the order of it is just.
Oh, so you put like those there?
Yeah.
But that's probably because this was over here and that was over there.
Yeah, that's what I was saying.
And that's fine. No, it doesn't matter, because that you probably put this portion of your Punnett square is probably here and this portion was probably over here.
Okay.
And that's perfectly fine. As long as you have these, it doesn't matter where they are up there. Okay? All right, and then our FOIL method, obviously we would take our original, and a lot of you will probably use this because it's just a little bit easier to see. But some people... Oh, wait, that's not the way I did it before, just so I don't confuse you. I went this way and then this way. So that we don't have a crossover, so we have our donut. Got it? All right, good, excellent. All right, so while I'm erasing this, I want you to go ahead and pass your papers to somebody at your table, and I want those to be turned in, and then take out your blood typing notes. Let's do that in a matter of 1 minute. Remember, we're on a shortened schedule, so we need to move quickly.
Can I go get some tissues?
Hurry up. Hurry up, I said. Don't, because the cord is just not
Sorry,
there.
I forgot.
That's fine.
About to hit me.
So with it. Miss school.
All right, I'm ready in 30 seconds.
1, 2.
All right, and my turn. With blood typing, remember, just as a review, let's go back. Let's try not to look at our notes if you can. If you need to, then refer back to them. Human blood type is passed through what type of way do we get this human blood typing, Madison? Codominance. What does codominance mean, Quatoria? And it's okay if you need to look back now. That's how we're refreshing our memory. Give her a chance. Give her a chance.
When offspring shows both.
When offspring shows both alleles. Very good. And then moving on from there, what did we have here? Basically what Quatoria said. You can have two dominant traits. What are the four possible phenotypes for blood types, Rihanna?
A, B, A, B.
Type A, type B, type AB, and type O, right?
Yeah.
What's the dominant blood types, Jenny?
A or B.
A and B are both dominant. What's the recessive?
Oh.
Oh, all right. Troy, tell me. Blood types are none other than what? How do we get the blood types? What are they?
Presence or absence.
Of what?
Antigen.
Antigens. An antigen is basically what helps us to, it helps us to kind of fight off diseases. So the red blood cells kind of help the white blood cells. So these are these little markers that are on what?
Your cell.
What type of cell? What type of blood cell?
White.
Red blood cells. Your blood type is determined by your red blood cells. Your white blood cells are what's going to attack the wrong one. So if you're type A, then tell me a characteristic about your red blood cells, Brennan.
It's pro A and anti-B.
Pro A and anti-B. Why is it pro A? What does it look like? What does your blood cell look like? If we had to draw it like a cartoon, what does it look like? Tell me. Tell me, Raji.
It's like a blood cell, then around it's like A's.
It has A's around it. It has these little A markers around it. If you're type B,
You're pro B, anti-A.
thank you, Rajulin.
Oh, I didn't know that.
Chappie.
Sure.
But tell me what it looks like.
It has B's all around.
B's all around it. All right. What if you are type AB, Drika?
I had.
Okay. Question?
I don't even know.
I don't know what. You were here yesterday, but this sheet was something that was collected.
3 in our basket.
Oh. So if you are type AB, what does
A's
it look
and
like?
B's all
A's
around
and B's. But tell me some more information about it, Simon.
It's unique.
Come on, Simon, speak up. Hurry up.
Oh, isn't it like pro A and pro B?
It's pro A and pro B. Hernandez got something else? It is the universal receiver. What does that mean?
You can get blood from anybody.
And if you're AB, you can get blood from any blood type. All right? Oh, can you give? You can. Oh, tell me about the O blood type that we drew over there. Jenny.
It's anti to A and A. I mean A and B and AB.
Well, A and B is period. That you can just say A and B because AB is a combination of the both. So it's anti-A and anti-B, meaning what? Kylie.
It's you can only give in the type O to the type O.
Only O can receive O. But what about the other ones? Can O give to the other ones?
Yeah.
So therefore O is a what?
Universal donor.
Universal donor. Very good. What will happen if we gave an O blood type an A blood type? Brandon. It will fight it off. And what will the blood do? Clump. It will clump together. And that could cause a what? A blood clot, definitely. And then the person can actually what? Die. Any questions about that?
Wait, so
Yes.
when people just form blood clots, like
That's not the only reason why they form blood clots, but that could be a reason why they would form a blood clot. Raji, question?
Is it possible for like two parents to have like AB or
Oh, we're about to talk about that. Let's hold that thought. All right. So we said that it would clump together and form. That is actually called agglutination, which means a glue, like it glues together. So that leads us to our next point because here we have 3 blood type alleles. What is that?
IA.
Okay. So let's go ahead. Let me go ahead and write that.
you said the compound was called
Agglutination, and we're going to write that over here in a second. All right. So you have IA,
IB.
IB,
and I.
and then a lowercase I. Those are the 3 alleles, okay? Because what is happening is this I stands for agglutinogen.
I gotta write that down together.
This should be an I. Agglutinogen. And remember, iso is like isolation, which means that the I means that this is type A, which is the antigen. Remember, this represents the antigen. So this type of blood is only going to accept this A. Anything else is going to agglutinate. And agglutinate equals clumping or gluing together. And that's what we don't see. Is there an A here?
Together.
No.
This is a no-no. We don't want this. All right? And remember, that's how we determine, that's how blood types are either mixed. When you do a transfusion, you want to give them the proper blood so that you do not have agglutination. You don't want that clumping. I'll give you a moment to write that. And then we'll move on to get to this chart so that we can talk about how this relates to you and what you get from your parents.
Could you find out your own blood type at home or like?
No, not at home.
So it's a lie. Every time people like you want to find out your blood pressure, and then they try to tell
Your blood type, not your blood pressure.
I mean, yeah, your blood type.
What's your question again?
Like, you know how like certain websites they say you can find your blood type by like answering a couple questions.
That's like a predictability of it. All right, can I move on now? Yes? Okay, so then where we're going to start first is we're going to start. Let's start over here. And I'm going to just skip spaces for a second because so far what we know, there are how many blood types? 4, but we have 1, 2, 3, 4, 5, 6.
Does that go back to my question?
Huh?
Does that go back to my question?
It does, and so that's what we're going to do. That's it, because as you can see, phenotypes, visual, and genotype. So let's start with what's one of the blood types?
A.
A. And we're going to write type A. All right? What does it look like?
It's a red blood cell with A's around it.
With A's around it. Should I do this in a separate color?
Yeah.
Yes? All right, so we have type A. It's a red blood cells with A's all around it. What do you think? First of all, what is a genotype again? The alleles gathered from who? Your parents, right? So in order to be type A, what do you think you would have to gather from one of your parents?
A type A.
A type A. What is another possibility of what you could gather from the other parent?
O.
A type A. Okay, let's stay there for a second. Because in order to be type A, that means both parents would have had to give you A. That's one possibility. So what would be a genotype based on what information you have right now?
Dominant A recessive.
How would we write it?
Dominant A recessive.
What are the alleles for blood type?
Dominant IA.
IA. That's from dad. IA from mom.
Yeah.
Does that make sense? Okay, that means dad gave you this isoagglutinogen. Mom gave you this isoagglutinogen that had the A antigens. Huh?
Can it be a recessive one?
No, there's the only one that's recessive is O. Remember, A and B are both dominant. Okay?
O,
Questions?
O is the-
O is the recessive. Look further up in your notes where we said which one was.
No, I'm saying O is
Yes,
the I.
because remember, that's a good question. Let's go back to that. Remember, in order to be an O blood type, that means what does your blood look like?
It has nothing.
It has nothing.
No antigen.
There's no antigen linked on here. O means 0 antigens, okay? Any questions about this? All right. Is there another way to be an A blood type?
Yeah.
No.
How, Jenny?
You can either be A negative or A positive.
AB.
Well, you could be A negative, A positive, but what I'm asking you, is there another way? Are there other things that your parents could give you that would make you a type A blood type?
Right?
They could. Okay, so explain that to me.
Because we said that the O blood type it has no antigen. So if you pair with A, wouldn't it give you another?
So give me an example of two parents coming together and what they would be in order for the child to be A.
Okay, so if one parent, the mom has type A blood, right?
Would that look like this?
Yes.
Okay.
And then the dad has type O blood.
What would that look like?
The lowercase I.
What would the child be?
They would be type A.
Isn't there like
I'm
math, like
smart.
a certain number times 1?
Mm-mm. I'm going to show you in just a second. So this child would definitely be type A. What would their blood look like?
The same as type A.
It would be the
Yeah.
same as type A like
O
this
doesn't have
because
antigens.
O doesn't have any antigens. A is dominant, so therefore the child received the A antigens, which made the child an A blood type.
I need to go to Harvard.
Any questions about that? All right, so then let me ask you. Well, I'll do that afterwards. Let's get this done so that we can. I don't want to confuse you. All right, so then what's another type of blood?
Type
B. So here we have type B. Right now, talk with your group about what this should look like.
It has fever. Do the A and the B have to be capitalized?
Because they're dominant.
Why are you looking at me?
All right, Antasia, what would the blood type look like for a type B? A blood cell with B antigens. I want you guys to be using those words, B antigens. Antigens. Everybody say antigens. Okay. With that information, what would the genotype be, Yashana? What would the I look like? A capital I. And what would the B look like? A capital superscript of the B, super above. And then what? Capital I, capital B. Talk with your group right now and talk about the possibilities of it still being another type B. Keelan, tell me, what would that person's blood look like?
They would have B antigens around it.
So you have a blood cell with B antigens. Very good. Tavarsier, tell me, what would the genotype be for, what is another genotype for a type B blood type?
Capital I. With capital I B.
Capital IB, dominant B.
A lowercase I.
A recessive I. Any questions for that? All right. What's our last blood type?
Type A, B.
Type O.
Oh. We not doing AB?
Is that our last blood type?
No.
Do we have another one?
Left AB.
We have an AB. Good. But we're going to talk about O right here.
Oh, okay, gotcha.
Well, actually, let's talk about AB first. It's okay if you wrote it. Oh, you wanted a marker? Okay, we'll do O. Did everybody write it?
Write it yet.
Okay. Who did not write? Who wrote it? Did you write it in pencil?
Yeah.
Okay, just erase it. So we'll do AB first. What would the blood look like for type AB? Jalil,
Blood vessel. Okay, yeah, blood.
not blood vessel.
Red blood.
Cell, red blood cell.
With with AB around it.
With AB, what? What are those called? What are these called again? Antigens. Very good. Thank you. Talk with your group about what the genotype would be. Come on, sit on the other side so you can stay looking this way. You don't have to keep turning your head around. Sit on the other side next to Madison. Hernandez. Dime. What would the genotype look like for this? Okay? Capital I. But what would we call this? How do we say this genotype? Huh? That's what the I represents, but how would we call this genotype? And you told me this, right? But what would we call this? The blood types are, because what have we been calling like the colors? Dominant B, recessive B, dominant. Remember we've been saying that? This is still genotype, so how should we call this?
Dominant I subscript A. No.
Dominant A.
Dominant A,
Dominant.
dominant B.
Oh.
Because these are dominant blood types.
So
All
you
right?
have to say
Is there any other way to do AB?
No. No.
Who said yes? How, Simon?
Those are the same thing though. Means add the I, A, I, B, and then
Like this?
put an A. And then I, B.
But wait.
And then, hold on, shh. And then do what?
The D, and then have a lowercase I.
How many genotypes do you have here?
3.
How many parents do you have?
2.
So how did you get this other one?
somebody else.
Another man.
Okay, so guys, quiet. Hernandez asks, could we do this? If one parent has A and B already,
Oh, yeah. With the I.
and one has what? OB?
I.
Lowercase I.
Lowercase.
Oh, I'm bad. I'm sorry. I got all these markers in my hand.
Can you do that?
Yeah, because one parent can have A, B.
You actually cannot do this because remember,
Wow.
this is what does this parent look like?
A parent.
No, what does if a parent, don't write this down. I'm just writing this so that you can see a visual. And this leads us to a good point. If a parent is type AB, what is their genotype?
I dominant A, I dominant B.
I dominant A, I dominant B. Which means that when they partner with someone, let's say this is a dad. So, this leads me to a good point. When they partner with a mom, first we have to do a what? To figure out the possibility or the chances. We have to definitely do a Punnett square. So let's say that we put the dad here. What's going to go above this box? I dominant A. Or dominant A. What's going to go above this box? Dominant B. Are we ever going to put IAB up here?
No.
No. So they can never give an IAB because their Punnett square will look like this. Their genotype, will look like this. Does that make sense?
Yeah.
Now, let's say the mom is type O. What? Oh, well, we didn't do O yet, so let's not do that. Well, yeah, let's do it. Let's say the mom is type O, which leads us over here. So we have type O. What does the blood look like? Drika Scary.
Nothing. It's just a blood cell.
It's just a red blood cell with no antigens on it, right? What would be the genotype? Talk with your group first. What would be the genotype?
Lowercase
Lowercase I.
Kylie, what's your group say? Kylie says recessive I or recessive recessive. All right, Jenny?
Lowercase I.
Thumbs up if you agree with this. Thumbs down if you don't. Good. We're all in agreement because this is going to be the blood type. Therefore, Madison and Ahmad, pay attention up here. What would be the mom's Punnett square here? What would go here?
Recessive I.
Recessive I, recessive I. Now let's talk about the possibilities of their offspring. What would this offspring be?
Dominant A, recessive I.
Dominant A, recessive I, which means this offspring's blood type, if this was the genotype of that offspring, that blood type would be what?
A.
Type A. What would this one be?
Dominant B, recessive I, so they would be type B.
So they would be type B. What about this one?
Dominant A, recessive I.
A blood.
A blood,
Dominant B, recessive B. B blood.
B blood type. Will these two parents ever, will this mom ever get a child with this dad that is a type O?
No.
Never.
It's 50.
It's dominant. She has the recessive. They will never. They'll either get a child that's going to be A or a child that's going to be B. All right? Now, what I want you to do on your side over here, actually talk over with your group, with your partner. Talk about, I'm going to erase this. Talk about how can a child be type AB? Talk about a Punnett square, what the parents have to be for a child to be type AB.
What is
20 seconds.
This weekend, do business close early on Veterans Day.
Business are probably closed, period.
Really? I thought they did close early or something. Oh,
All right.
I thought it was.
So now, let's talk about that. What would the parents look like in terms of blood types, not if they blood types, for a child to be type AB? Yashana.
The mom gotta have.
Shana, go ahead.
Mom gotta have A, and then the daddy gotta have B.
So the mom has to be type A, and the dad has to be type
B
B.
or A?
So let's figure out this Punnett square. So on the side, I want you to write mom type A, dad type B, and let's figure that out. You don't need to write all of these words. Just write mom type A, dad type B. Here we're going to put mom, and here we're going to put dad. Now, before we do that, we need to give us some information. Mom's possible what? And we know mom is type A, but we also know what about type A blood? Not possible donor. What did we know from this chart about type A? Huh? There's two ways to have type A blood type. So we're looking for mom's possible genotypes. And then therefore we need to know dad's possible genotypes. Okay? So what are mom's possible genotypes? Raise your hand and tell me. Chappie.
She can either have dominant A, dominant A.
So she can either look like this, or,
She can have dominant A recessive I.
alright, Troy, tell me dad's possible genotypes.
RB.
I need to know, you need to use those words.
Oh, dominant R
Uh-huh,
and dominant B
okay.
and dominant R.
Dominant B is what it's called though.
Oh, dominant
Here we
B.
go. I dominant B.
Or I dominant B or and lowercase r.
Recessive I. Alright, so then we need to try them all. But let's just pick one and see. Having this information is kind of using your eye before you try them all. Talk with your group and talk about what two possibilities you should use. What should the mom be? What should the dad be? Take 30 seconds, talk with your group, and then be ready to let's do it. Turn your homework in. 5, 4, 3, so what? Why didn't you bring a nut? You need to hurry up. We're about to start what? Okay, make sure you turn your homework in. Alright, are we ready? So, what did you come up with the possibility for the mom to be? Quatoria. What was your parental possibilities, I should say?
We said that it could be dominant A.
So you say who could be? I need to know.
The mom.
The mom would be
Dominant A, dominant B. And that would be dominant B, dominant B.
the dad would be dominant B, dominant B. Let's try this out. What's the chance of the child's genotype here?
Dominant A, dominant B.
Did that prove what we're looking for so far?
Yes.
It did. But all of them would also be the same. That's why you raise your hand. Yes.
Well, both parents like have A, B, so like what is everyone?
Both parents would have, well, if both parents had A, B, that means that their genotype would be A, and then B, A, and then B.
Like, is there both have like two A's, like two B's, like
No, because you only have two parents. All right, so in this scenario, all of their children would always come out to be type AB blood type, right? What if we use this scenario and this scenario where they're both recessive?
It would be 75%.
Would they ever get a child that's AB?
No. Well, yes.
Yeah.
Yeah, because they both have a dominant A and dominant B. Remember, that's co-dominance. Will they ever have a child that's O if we mix these two?
Yes.
Yes, because they both have that recessive. What if we took this blood type where the mom carried the recessive O and mixed it with this blood type where the dad was dominant B?
It would still be dominant B. There'd be a B blood type.
Would there be an AB blood type?
Yes.
There would definitely be an AB blood type because we still have a dominant A and we have a dominant B.
Oh.
Those will mix. You can do the FOIL method to figure that out as well. So we did the FOIL method. We have,
It's okay, Miss Williams. You don't have to do it.
Miss Wiggins, do you want us to write that?
no, I just was making the example. Did everybody see it though?
Yeah.
Okay, because whenever there's a dominant's always going to be there. So both, and remember, Simon, stay with me, Amon, stay with me because I see you going to La La Land. If there's a dominant, just like any other physical traits we've been talking about, if there's a dominant, the dominant's always going to be there. All right, because that's the first genotype, that's the first allele. So therefore, blood types have dominance, co-dominance. Blood types have two dominants. What are they? A and B. So if parent 1 has an A blood type and parent B has an A blood type, their children are going to eventually have them both.
Right.
No matter what. That's with this scenario, with this scenario, with that scenario. Got it?
So, if
I'm sorry, 1 second. While we're doing this, I want you to go ahead and flip your papers over really quickly.
so if the child doesn't get like AB blood type, but the child's like kid gets AB blood type, is that because of the parents?
If the child does not get AB blood type, but the kid, say it one more time.
Okay, say
I'm sorry, I can't hear because the back group is talking. I'm sure you can benefit from this question.
say parents have a daughter or something, and they both have A and B blood type,
But I need to know when you say they both have A and B blood type, are they type A or are they type AB?
The mom's type A, the dad's type B, but the daughter gets type B blood type, but the daughter.
The only way the daughter can get type B blood type if the mom is A and the dad is B is they both have to be, one of them have to be, the mom actually has to be recessive, has to have the recessive trait.
But if the
And the mom
daughter's-
the mom would actually have to look like this. And the dad would have to look
and then,
like this. The dad would have to be full dominant because then this possibility would be where the child would be type B. Okay? Good question. That means you're thinking it through. All right, looking at the back just really quickly, what we're going to do is we're going to come back to this back part tomorrow because I want to build on into this. But we are going to go ahead and look at who's your daddy because we do want to get through that. But we'll come back to this so that we can have more practice. Talk to your group right now about what you learned about blood types while you're putting up who's your daddy in front of you. And we should really get through this, so I do not want to take a lot of time talking and playing. We are going to have fun with it, but I don't want to take a lot of time playing. So, welcome to Can't Get Right Hospital.
What?
Because what's happened here is there's been some moms that have had some babies. And these moms do not have carbon-like qualities, if you know what I mean. Instead, us, the hospital, we had an error. We made it. We messed up. So therefore, we kind of switched some babies at birth. So now we got to figure out who's your daddy. And just like on Maury, we need to figure out if you are the father or
You are the mother.
Maury, you are not the father. So with that being said, let me introduce you. I'll wait. Let me introduce you to our babies. On your sheet, okay, good. On your sheet that you have in front of you, there's a couple things that we're going to write down and a couple things that we're going to talk about. You notice that on your sheet you have the traits. The traits that you have in front of you are widow's peak and earlobes and blood type. This information, when I show you the babies, the baby's going to tell you, or I'm going to tell you these traits, whether the baby does have a widow's peak, whether the baby earlobe, and we're going to talk about widow's peak because normally babies aren't born with hair, but for this sake, these babies were. Or later on in life, we figured out that the daddies got switched. Yes. Come up and get it. But earlobe, we're going to talk about that. But let's talk about these traits for a moment. Gentlemen, well, not gentlemen, but people who have widow's peak, normally I call it the Batman, where your hair kind of peaks right here like a little mountain. Sometimes, Troy, sometimes gentlemen have it and don't know they have it because when they get in that jump, they cut it off. So if you have, and ladies, sometimes we wear our hair to the front of our face, so we don't know. I don't have one. But if you have your hair on the front of your face, even you gentlemen, kind of pull it back and see if you got a little widow's peak. And it would be, this would be your head or your face, and your hair would kind of come there. And gentlemen, you would notice if you had it, because even if you shaved it off, because it'd still be a little space there. Okay? So that's what a widow's peak is. Shh, quiet. Widow's peaks are dominant over no widow's peak. So using this information, we'll have to figure out what the genotype is for that. The other thing is earlobe attached. Free earlobes meaning that they come away from your ears. So you have like a loop. This would be your head, and this would be your ear, and it loops away, kind of. Maybe not a whole lot, but they're attached earlobes, meaning this would be your ear, and there's really no looping away. There's no hook underneath. So check and see if you have an attached or a free earlobe. All right. So yes. No, yours free. Yes, a little one. All right. Eyes up here so we can get through this. As we go through, I'm going to tell you information about the babies. All right. So baby number 1, what you're going to be writing in the information for the first one, it asks for the genotype. You're going to write down what the genotype for the baby. Now, it may, yeah, you see it? And we have 4 babies. So let me just get to it and go ahead and show you baby number 1. Baby number 1. Aww. Baby number 1 has no widow's peak and attached earlobes with the blood type of A.
So where do we write this in the box?
You're going to be writing some information in the box.
So we write a little W.
No, he has one. So.
No, little W, big E,
Recessive.
and A, right? No.
I'm going to write mine over here right in front of baby, right above baby 2. So I'll actually write under here. All right, so baby number 1, no widow's peak. What would his genotype look like? Recessive W, recessive W. And maybe I'm going to write my W's rounded so that it's very clear that it's recessive. Attached earlobe. Recessive E, recessive E. It's attached. All right. Blood type.
Dominant A.
It's type A. So what is there more than one possibility?
Yeah, dominant IA, dominant.
It could be dominant IA
And recessive I.
or dominant A, recessive. All right, here's baby 2. Aww. No, how do you know? How do you know, Rogerlyn? No widow's peak.
Recessive W.
Recessive W, recessive W. Free earlobes.
Dominant E.
Oh, that's the only one?
Or dominate E.
Dominant E or recessive E.
Dominant E or dominant E, recessive E.
Yeah.
Blood type is B. Raise your hand, Brandon. All right. Baby number 3. Just you can't really see, but this baby has a widow's peak. What is the genotype?
Dominant W, recessive W. And
It could be dominant W, or dominant W, recessive W. It has free earlobes. Dominant E, or Jalil? Dominant E, recessive E. The blood type is B. Tavarsia, give me one possibility of the blood type for this baby.
Blood type B.
Blood type B.
Dominant I, dominant B, right? Yeah.
Dominant I, dominant B.
Come on, boy.
You need 2 because you got 2 parents.
Oh, and the same thing.
Okay. What's the other possibility, Antasia?
Recessive O.
All right. Ooh, didn't do that, right? All righty, are we good? Okay. Then baby 4.
Oh, that's daddy.
Baby 4 has a widow's peak.
Dominant W, or dominant W, recessive W.
Attached earlobes, everyone.
Recessive E,
Recessive B.
Talk it over with your group about this blood type for this child. Type O. And in your box, you might want to write what type that is just to remind you so you see it immediately. Jedison, what's the genotype for this child? I know you weren't here, but that's why you're supposed to look over. We got to help him out. All right. Preguntas. All right. Let's go ahead and then look further on our sheet, because what we're going to do now is we're going to get some information about the parents of these babies. We don't know. Remember, we don't know who the daddy is. So we're going to need to figure out who the daddy is. But we do have information. We have information about both, or we can figure out information about both. We just got to figure out who this daddy is. So for one of the babies, we have Julia. She does favor her a little, doesn't she? Alright, so we have to figure out some information about both of these parents, so therefore we can then come to a conclusion on whose baby is this. So Julia is married to John, and Julia, what you have first? Let's look at Julia, even though you have John written down first, let's look at Julia. So Julia has, no widow's peak. So based on the information that you have, let's reiterate. Somewhere on your paper, let's actually put this so that you can see it. On your paper, you do need the little chart here where capital W equals widow's peak.
At the top.
Did I put it at the top? Okay, good. Thank you. It is at the very top where you have your chart so that you know what's dominant, what's recessive. So Julia has no widow's peak. What are her possible genotypes?
Recessive W, recessive W.
Is that it?
Yes.
Okay. Julia's earlobes are free earlobes.
Dominant E, recessive E.
Dominant E, recessive E,
Or dominant E, dominant E.
or dominant E, dominant E. Julia's blood type is AB.
Dominant A, dominant B.
Dominant B.
Any questions for that? No? Are we good? Yes.
John has a little
All right. So then let's talk about John being Julia's partner here. So before we reveal who John is, let's go ahead and get some information about John. So John has a widow's peak.
Dominant W, or dominant W, recessive W. Recessive E.
Oh, recessive E, sorry. I was trying to think ahead of something. Recessive E, recessive E,
Dominant B, or dominant B, recessive I.
because he's type B. She sure is.
Thanks, I know.
You don't get candy when you're doing what you're supposed to do.
Say a lot of words, no more donuts.
Alrighty, any questions for this? Let me see to fix this tape.
No, but we gotta do the box.
Miss Wiggins, now you know you could have drawn this box better.
What I put? I want to put the box in your paper just so I see it. All right. So what you're going to do is you're going to take a moment and make sure I'm doing this correctly. Because right underneath there it says, now determine the possible genotypes of the babies born to John and Julia. Use the Punnett square if needed. Only if you need it. So you're going to look at the widow's peak. You're going to do a Punnett square, the possible Punnett squares for the widow's peak. I just put it there if you need it. That's why I drew it like that. Earlobes and the blood type. Take a moment and discuss that and put the possibilities.
Wait, I have a question.
Yes.
Do we only, for the widow's peak, can we like,
You would have to do possible Punnett squares for all.
huh?
You would. Question here is for the widow's peak. This is the dad's possibilities. So that means you would have to do two Punnett squares. One with this possibility, one with this possibility. Because we got to figure out this baby. We got to figure out who the daddy is. Now, in this instance, go ahead and take a moment and do the Punnett square so you can kind of get all the possibilities of the babies. Use a, you can take this scrap paper and rip it in half. You would have to use both possibilities. You would have to do it. You would have to do it one time.
And then another time.
Guys, up here again. I want to say it again. You're figuring out the possibility. You don't know exactly what John's genotype is. You just know his trait. So that means you would use Julia's genotype with this possibility and do it upon a square again. Julia's genotype with this possibility. Because then you're going to